Hello, brilliant economics students. Today we're going to be reviewing for Unit 2 of AP Macroeconomics. So we're starting off with graphs for loanable funds. So draw a correctly labeled graph showing equilibrium in the market for loanable funds. This is loanable funds graph. So let's just start with that. So we draw our X and Y axes. So what is on each axis? The x-axis here, let me do it in white. That is the quantity of loanable funds. This is a quantity. There we go. And then over here, this is the real interest rate. INTEREST rate. This is the real interest rate. So these are our two different axes. And we draw our demand curve as, and so this reflects the idea that if more people want to, the lower the interest rate is, then more people want to invest in something. I will be more likely to purchase a house and invest some money into a house whenever I take out loans that I have to pay less interest rate. If it's 5% interest rate versus 2% interest rate, then I'll be more likely to purchase a house if it has 2% interest rate. And so that creates this downward sloping curve here. So this is our demand. D1, this is investment. So I'm just going to write equals investment. INVEST mint. Here we go. Investment. And then we have the supply curve. This is the total national savings. Um, so this is, I'll just write S1. This is national savings. Do it in blue to keep up with everything. National savings. And so this slopes upward because if I am loaning my money to the bank to get some interest or whatever, I don't need to spend that money right now. I will be more likely to save money if I get more return on whatever I save. More people will save at this market for loanable funds as they get more out of their savings. So that creates this upward sloping supply curve. The supply curve is national savings, and the demand curve is investment. So now let's just kind of draw these equilibrium quantities. This is Q star, and over here it's R star. R star. All right, so we have a investment tax credit. Investment, meaning we're going to look at the demand curve, the investment curve, the demand curve, we're looking at that. And tax credit, people get benefits from investing. More people will want to invest, shifting the demand curve, the investment curve rightward. So this is now Q2, Q2 and R2. All right, let's look at 1B, where we basically draw the same base market here. So I will go boom, D1 is equal to boom, S1 is equal to, and I will copy over my labels because these labels are the exact same thing for every single. national savings, investment, and real interest rate. So now let's actually examine this. I guess I'll draw these equilibrium quantities, Q star and R star. So let's see here. If the government moved from a balanced budget to a budget surplus. Okay, so we know we're going to be looking at the supply curve because the budget surplus is a measure of government savings. So we're going to kind of look at the savings aspect. We know that national savings is equal to the private savings plus the public savings. Private, I'll just type it out, plus the public savings. And nothing is changing with the private savings, so we don't really have to worry about that. We just have to look at the public savings, the stuff that the government is doing with their savings. So what is the public savings? What does the government save? So the public savings, I'll just- the public savings, I'll just write S, is equal to taxes minus the government spending. We have whatever they make in revenue from taxing its citizens minus whatever the government spends on whatever public goods and services. Whatever they have left is savings. So taxes minus the government spending is the government savings. And so it was a balanced budget. It was equal to zero. So this is beforehand. But afterwards, T minus G is now greater than zero. Could be $1 more. They might have gained, for some reason, they might have just spent one less dollar on government, but that would be an increase to public savings. So I'm just going to say public savings went up. Public savings went up. And that's the only thing that's changing. It doesn't say anything about private savings. It just says, hey, it went from a balanced budget, it equals zero, to there's a budget surplus. The government has spent less money than it would be to break even. So that means we shift the supply curve right. I'll do this in green. So this is S2. Q2, R2. Because the public savings went up, the national savings went up, so the savings slash supply curve shifts right. And that is as simple as that. Question two is a bunch of present and future value stuff. So we're going to just write the formula for the first one and then start substituting. So we're going to say the future value is equal to the current value, the present value, times 1 plus the rate to the number of years. So you get more and more for each. For example, for this one, we could start with 300, and after the first year, we would make 307. But then the second year, we would start at 307, and then go at 7% interest rate and get some other value, which is greater than 314. So this kind of helps simplify this formula by just having this exponent. So this future value at 4 years will be the present value of $300, 300 times 1 plus 0.07. This is not 7, this is 7%. 0.07 to the power of, not n, 4. 4 years. And so if we shove this into a calculator, I'm going to go write this over here because I don't think I have enough space. But this is in dollars. Very important that you write units because it is it is money. It is not just 393 somethings. It's, by the way, it's 393.24. We got to round up that penny because the actual one is 2388, and so we just got to round up that penny. Here I'm not going to rewrite the formula, but I will show the substitutions. I save $12 for 13 years at 14% interest. How much do we have after 13 years? All right, so our present value, 12. Currently, you have $12. 12. I save for 13 years at 14% interest. So 1 plus 0.14. How many years? 13. And now some calculations that I seem to be getting 65 and 91 cents. And so the idea with these types of questions is with this formula, you could be given any one, two, three, four. You could be given any three of these variables and asked to solve for the other. You could be given these two and asked to solve for n. You could be asked to solve for r, and that is just a test of your algebra skills. And so you can just solve for those with some basic algebra. Here is a question that kind of compares these. Would I rather save $15 for 10 years at 5% or $5 for 15 years at 10%? All right. So we have, I'll do this one in blue over here, and I'll call this FV1 for just like the first set, and I'll substitute. All right. So this is $15. So is this is our present value times 1 plus our rate, which is 5%. So 0.05. 0.05. That was a horrible 5, and it's for 10 years. Versus, I'll do this one in green, FV2 is, we start at a principal value of $5, 1 plus our rate, 10%, so that's 0.1 to the 15. And then we will see which one is the highest. Let me go calculate these. So make your predictions if you didn't calculate this yourself. All right, this first one is $24 and 43 cents. And this other one is $20 and 89 cents. So this second one is what you would rather do. You would rather have $5 at for 15 years at 10% interest. Right, that is a lie. You would rather have the other one. I am slow. You would rather have the more money, probably. So 15 years, $15, 10 years at 5% interest. This one. I don't know why I did the bottom one in green, or the bottom one in blue, but you would rather have this future value one. All right. Philip J. Fry has 23 cents. Very cool. On a savings account in the year 2000. He cryogenically frozen and wakes up 1,000 years later. 1,000 years in the future. All right, that sounds like an N of 1,000 to me. And he has earned a steady 2.1% interest rate. How much money does he have now? All right, so we just have to calculate the future value there using this information. So the future value is our present value, which is 23 cents, 0.23, times 1 plus our interest rate, which is 2.1%. Do not mess this up. It is 0.021%, not 2.1, not 0.21, it's 0.021 to the power of 1,000. It is 1,000 years. We gotta make sure that that point in there. Let's calculate this. Now, if I was in like a middle school math class, I would be like, it's like 1 plus a tiny number, and this literally you started with 23 cents. Like, there's no way it would be a lot. But it's it's kind of a lot. You got 244, and then I'll put the commas in there for good measure. 0.045, and 90 cents. You know, just a measly $24 million. I mean, it is 1,000 years later, but ladies and gentlemen, that is compound interest. All right, so we have a couple of multiple choice questions up here. When a country saves a larger portion of its GDP, what will it have? So this is, it will save more. The people who save the money into whatever it is, like a bank, for example, if I put some money into a bank, more people will be able to and buy a house, which is investment, or more people will be able to buy a tractor or whatever it is. So there's going to be more capital, and because there's more stuff to build stuff, there's going to be more productivity. So that one was a tricky question because you kind of have to think of it both ways. If I save money, other people can use my money to invest. So that one was a bit weird. All right, if Procter and Gamble sells a bond, it is so a a bond is a certificate of indebtedness. If I have a bond in Microsoft, then I say it's sort of like a bank loan, but backwards. They are getting my money. So it is A. It is basically a backwards bank investment. I am giving a company my money so that it can do some work. I'll probably get some interest on it like a bank, and it's direct. It is I am directly giving money to whatever company, in this case Procter and Gamble. Indirectly would be some through a method such as a bank, but directly is either a stock or a bond. All right. Next question asks, long-term bonds are generally, so if a bond is if you loan something out for longer, something else could happen. Something more likely bad can happen to whatever it is. You can uh, have some kind of economic crash or whatever, and it'll be worth not as much or whatever it might be. There is many catastrophic things that can happen over a longer period of time, and a longer period of time leads for more chances of these catastrophic things to happen. And so there is more risks, and because if something is more risky, you will have to pay a higher interest rate because it is more risky. It is C. I'm not entirely sure what happened to question 6, but we have question 7 next. So it says, it is claimed that mutual funds have two advantages. Mutual funds. First is to allow people with small amounts of money to diversify. That is indeed true. The second is mutual funds provide the skills of professional money managers who buy stocks believe will be the most profitable and thereby increase returns on their savings. Well, let's see. I really like the first one because someone who can kind of invest if they don't know what the heck they're doing. So I like the first claim. The first claim is very cool. But let's see the second claim. Provide the skills of professional money managers to be the most profitable and thereby increase return. That is not necessarily true. They may not be the most profitable because the idea is to just diversify, and so you wouldn't just want to put all of your money in one. That's what the point of this is. And so it is not necessarily true of the second. So D would probably be the best answer for this one. All right. Suppose that a closed economy is worth 11,000. All right, we have a closed economy. That is cool. We have the GDP of 11,000. Taxes are equal to 1,500. Consumption equals 750. Government cheap purchases is equals this. What is a national saving? National saving? National saving. Well, we know that in a closed economy, national saving, let's call this NS, is going to be GDP, which is Y. I don't know why I wrote G. Y minus C minus G. Y minus C minus G. So that is 11,000 minus, we don't need this 1,500. There is no taxes in national savings because that is subtracted from private savings but added to public savings. So when you add them together, they cancel out. It is not in national savings. So we're just going to subtract our 750 and subtract our 2,000. 750 and subtract our 2,000. If I can write. And that is left with 1,500 for our national savings. All right. Explain the difference between saving and investment as defined as an economist. Well, saving is money that you don't spend later, or until later. You're, you don't spend, you're saving it for later. It is, and investment is money that is being spent, that is being B BEI to, I guess, increase productivity in a sense is probably the best way to describe it. To, yeah, I guess, increase productivity. It is just, for the most part, it is an increased productivity. So I'll say that. Okay, so if I had some money that I didn't want to spend right now, I put it in a bank, that's some saving. If I put it in a stock or a bond, that is saving. I am not spending it right now for the purposes of economics classes. When you do not have money that you are not spending right now and you just put it somewhere, you are not spending it, that is saving. If I spend it on something, but it is kind of helping me with making money of some sort, it could be considered investment. That could be buying a house that I am not using, but it maybe for money purposes. And once I start using it, it goes under consumption. But if I purchase a tractor for my whatever company, whatever, that is investment. I am spending the money to help with some kind of productivity. So, now that we have that, if Betty buys a stock in Microsoft, well, she is not spending that money. She is not getting a good or service back. That is saving. She is saving it in a stock. If I build a new house, is that saving or investing? That is investing. We have built a house with our money. We have spent money on a new house. We've built it. We're not consuming it. We're not living in it. It might make money elsewhere, but it is an investment for whatever we're doing. If I buy new machinery for my factory, is that saving or investing? We are purchasing some machinery for our factory to help increase our productivity. That is investing. All right, this is another present value, future value question. So we have a current value of $333, 333, at an interest rate of 3%, so 1 plus. This is 3%. Do not forget it is 0.03. I was literally about to write 0.3. 0.03. Do not mess that up. Many people will mess this up, and this is just the first power. It is 1 year from today. 1 plus 0.03 times. I got 342 and 99 cents. That is B. This next question says, explain what we mean by most people are risk averse. Use the utility function in your explanation. All right. So the utility function is the idea that as our wealth increases, we get some different color. I'll do some blue because it's cool. Should probably label our axes. That is not supposed to be linear either. What in the world? We get wealth and utility. So this is our utility function. So at any given point, we have some wealth and utility, and increasing our wealth will increase our utility, but not as much as it. Let's see, let's go about the same distance. It is 3/4 of a finger. So it's like here, okay. And you can see that this change in utility, this could be happiness, this could be something else. But this change in utility here and here, if we started here, is so much greater when we lose that than if we win it. So, for example, if I said, flip a coin that I will If you land on heads, then I'll give you $1,000. If it lands on tails, then you give me $1,000. Right? So we have kind of the idea of plus 1,000 over here, plus 1,000, and minus 1,000. This utility here, the gain of $1,000 will not be as detrimental as the loss of $1,000, is the idea of risk aversion. People don't want to make risky decisions. And if it was like plus $1,000 and minus $500, we don't necessarily know that because we don't know the exact shape of this utility curve because it's different for different people. But we could confidently say, for the most part, that for this example, or just in general, that people try not to take risks because of that reason. So now I'll try and answer the question. People, uh, P-O-T-I-E-N, P-O-T-I-E-N-T, potential gain is outweighed, W-E-I, by the you because people try not to take risks if the gain slash loss is about the same because it will hurt their utility more losing it than it will gaining it.